All right, in question 42, we are talking about, and I'm going to go back, we're talking about r squared. Now, r squared we didn't learn about as much in class today, but I would like for you to know what r squared is. It's in your book on page 162. It's called the coefficient of determination. It says it is the variation in the values of y that is explained by the least squares regression of y on x. So r squared, and in 42 specifically, it says a study of class attendance and grades among first-year students at a state university showed in general students who attended a higher percentage of their classes earned higher grades. Class attendance explains 16% of the variation in grade index among the students. So look back at what r squared means. That sentence is r squared. So where it says something explained a percentage of the variation, that's when you're talking about r squared. And you're going to have to learn how to make that sentence. So class attendance explains 16% of the variation in grade index among the students. That means r squared equaled 16%. Now, what is the numerical value of the correlation between percent of classes attended and grade index? R squared is the percent explained by the variation, okay? Now, correlation is your R. So how do you get your R if you have R squared? And again, I know you're all thinking, what do? I take the square root. So the square root of 0.16 is your correlation, and I'll let you plug that in the calculator and take care of that for 42. But make sure to make a note of what r squared is also, and that sentence, that how you know it's r squared. Okay, number 44, predicting the stock market. So we talk about the stock market, and it gives us the mean of x, the standard deviation of x, the mean of y, the standard deviation of y, and the r value. Now, what percent of the observed variation in yearly changes is explained by a straight line relationship with the change during January? What is that question asking for? What percent of the variation is explained by this? That is asking for the r squared. Well, think about it. In this problem, we already have the r. The r is 0.596. How do we get r squared? We take that 0.596 and we square it, and that will give us our r squared value. So we get one, but we need the other, and that's how we get that. Okay, but remember, correlation is r. The percent that is explained by the relationship between the two, that is your r squared. All right, B, what is the equation of the least squared regression line? Now, basically, they've given us all 5 things just like we did the first time. And if you remember, we get B by doing R, which in this problem, R is 0.596 times SY, so the standard deviation of Y, which is 0.1535. Make sure you change it to a decimal. Divided by Sx, which is 0.0536. Okay, that will give us our B, and that's the formula. The formula will be given to you, but you need to remember it also. Then once we get B, we get A by taking the mean of Y minus the B we just got times the mean of X. And remember, the mean of Y is 0.0907, so we can go ahead and put that in for the mean of Y. 0.0907, and the mean of x is 0.0175. So remember, those percentages, you've got to be able to change them to a decimal and be okay with that when you're working these formulas. That will give you A and B, and then just remember the formula is y hat equals A plus bx, and that gives us the equation for that one. In 44 also, in part C, the mean change in January is 1.75%. That's the mean of x. Use your regression line to predict the change in a year in which the index rises 1.75% in January. Why would you have given this result? Why could you have given this result without doing the calculation? So in C, basically, it wants to know what your predicted change is in a year where the index rose 1.75% in January. Well, if it rose 1.75% in January, that's what you're plugging in for X, and you'll get the Y. Well, why you could know that without doing the calculation of plugging that 0.0175 in for X is because if you're given the mean of X, it will give you the mean of Y, and we had that. But you can go ahead, plug 0.0175 in for X in your equation, and it'll give you the predicted value for Y. That takes you through 44. We now go to 46. Question 46, if I flip the page, we start talking about residuals, I think. It says, the exercise on page 129, it gives data on the fuel consumption of a car at various speeds. Fuel consumption is measured in liters of gasoline per 100 kilometers driven. Speed is measured in kilometers per hour. A software package gives us this regression line, and it gives us the residuals. Now, you remember from class today, residuals are your observed Y minus your predicted Y. So basically, it's how far away from what you were predicted to get you are. If you are more than what you were predicted to get, you will have a positive residual. If you are less than what you're predicted to get, you will have a negative residual. So there's the equation of the prediction, and then there are our residuals. Now, it says, make a scatter plot of the observations, so the residuals that you're given. Make a scatter plot of them and draw the regression line on your plot. Now, I'll explain to you what a plot of your residuals looks like. A plot of your residuals. A residual plot, and we'll talk about how to get one in the calculator in just a minute, but a residual plot is at 0, and then each point is either above or below 0. So 10.09 would be up here. Then the next point, negative 2.17, would be down here. Then the next point, 2.24, would be up here. And yes, it has to go in order. Then the next point, and so on, negative 1.32 could go here. Basically, you need to plot all the points. 0 is your starting point for a residual plot, and you can scale it all the way up your y-axis and all the way down. But we're going to learn how to do these in the calculator soon, but for right now, they just want you to plot how far above or below a line are those. So what's the distance away from, and we're calling this the prediction equation, or the line. Okay, that's number 46. Would you use the regression line to predict y from x? So basically, if your residual plot that you make here, if there is no pattern to these, so if there is no pattern on the residual plot, then then it is a good prediction. So if our residual plot has no pattern, we have a good prediction equation. If there is a pattern, meaning if there's like a curve, if you can see a curve of the residuals, or you can see a pattern in them, then we do not have a good prediction equation. So it's a little different than what you're used to saying. But if your residuals are just scattered all over the place, that means the prediction equation is good, because that means there's some that are above it and some that are below it. So that means the prediction equation is pretty good. But if there's a pattern to our residuals, that means that we know when they're going to be below the predicted value, and we can see when they're going to be above the predicted value. Then that's not as good. So that's not what we need there. D says make a D. I'm not gonna ask you to do that. C, I am gonna ask you to do. Check that the residuals have a sum of 0. So add up all the numbers given to you above in 46 and make sure that they all add up to 0, and that will take you through problem 46. I will not make you do D. We will do D, part D of 46 in class, but do go through part C of number 46. And again, your residual plot, I'm giving you an example of what it looks like with the points. You just, if it's above 0, you plot it on the scale. If it's below 0, you plot it on the scale. Okay, 49 and 70 are coming up in the next.